In the wild, deception is not a trick. It is a survival strategy, a form of adaptation sculpted by millions of years of natural selection. And for many species, it is the only way to stay alive. Mimicry, the ability of one organism to resemble another, is among the most extraordinary phenomena in the animal kingdom. It can mean the difference between being hunted and being ignored, between catching prey and going hungry. Across the globe, countless creatures have evolved not to be faster or stronger, but to be something else entirely. Consider the monarch butterfly. Its bright orange wings serve as a warning. Monarchs feed on milkweed, which makes them toxic to predators. But flying alongside them is an impostor, the viceroy butterfly. Nearly identical in appearance, yet harmless. Birds that have tasted a monarch once tend to remember vividly, and the viceroy benefits from that fear. This is Batesian mimicry, where a defenseless species adopts the look of a dangerous one. This tactic is not limited to butterflies. Hoverflies, for example, mimic the striped appearance of wasps and bees. They are incapable of stinging, yet predators often leave them alone, just in case. The illusion is enough to protect them. But mimicry is not always one-sided. Sometimes dangerous species mimic each other, amplifying the warning. This is known as Müllerian mimicry. Monarchs and queens, both toxic, share similar colors and patterns. Each reinforces the other's reputation among predators. The more consistent the signal, the faster it is learned. Elsewhere, mimicry plays a very different role. In the rainforests of Southeast Asia, a predator hides in plain sight. The orchid mantis does not just resemble a flower, it becomes one. Its petal-like limbs sway gently in the breeze. To a pollinating insect, it appears to be a bloom, rich with nectar. But when it lands, the deception ends abruptly. This is aggressive mimicry, where predators mimic something harmless or attractive to lure in prey. In the oceans, mimicry reaches astonishing complexity. The mimic octopus, discovered only in the late 1990s, is one of nature's most versatile impostors. It can impersonate multiple marine animals, a lionfish with flared fins and striped warning patterns, a flounder gliding smoothly along the seafloor, a banded sea snake with only 2 arms extended, imitating the slithering motion of the real thing. What makes the mimic octopus remarkable is not just its appearance, but its behavior. It chooses which animal to mimic based on the threat it faces. It is strategic, adaptive, a performance artist of the deep. Not all mimicry is used to deceive others. Some creatures aim to disappear completely. The leaf-tailed gecko of Madagascar is a master of camouflage. Its body mimics the color, shape, and even the ragged edges of a dead leaf. By day, it remains motionless, nearly indistinguishable from the forest floor. Predators pass by unaware. Stick insects take this camouflage to another level. Some not only resemble twigs, but gently rock back and forth to mimic the movement of branches in the wind. This behavioral mimicry reinforces the illusion. Among birds, the potu is a quiet, nocturnal hunter that rests upright on tree stumps. Its mottled feathers and rigid posture make it look exactly like a broken limb. It doesn't just hide, it vanishes. Even among predators, mimicry can be used for exploitation. The false cleaner fish looks nearly identical to the cleaner wrasse, a species that helps remove parasites from larger fish. But instead of helping, the mimic delivers a quick, painful bite, taking advantage of the host's trust. This mimicry of service is rare and ruthless. Some of the most bizarre examples exist among caterpillars. The The hawk moth caterpillar, when threatened, expands its head and reveals eye spots that look remarkably like a snake's face. The transformation is sudden, startling, and often enough to deter predators. In the microbial world, mimicry exists on a genetic level. Viruses can disguise themselves from the immune system by mimicking host proteins. Even some fungi have evolved to imitate the chemical signals of their insect hosts, taking control of behavior and physiology in terrifyingly precise ways. But mimicry is not perfect. Its success depends on the predator's recognition or misrecognition. If too many harmless mimics exist, predators may begin to ignore the warning signs altogether. This delicate balance shapes the evolutionary arms race between model and mimic, signal and response. So why does mimicry evolve? Because in a world of constant pressure, every advantage counts. Every feather, scale, or motion that helps an organism survive longer gives it a better chance to pass on its genes. Over thousands of generations, these tiny advantages become dominant. The line between illusion and identity begins to blur.